Greetings, folks. Well, it's the second semester. We are getting into electricity and magnetism. And as we do, you're going to find that we're going to start dealing with mathematical entities that are a little different than what you're used to. And so this video is designed to sort of introduce you to some of those ideas. So sit back and enjoy. This is going to be a truly exotic introduction to the topic at hand, but just stay with me. There's a method in the madness. When I was a kid, we rather delusional middle school boys really did believe that the path to popularity was embodied in the ability to burp long and loud. So casting back to that time, let's say some entrepreneurial genius decides to capitalize on this and creates two products designed to help a guy burp. You and your friend are desperate for popularity, so you decide to try the products. The question is, what to buy? Your choices? There is Burp-A-Lot, which will give you for $10 100 glorious burps. Or there's Gas Gulp, which also for $10 will give you 100 glorious burps. So you buy Burp-A-Lot and your friend buys Gas Gulp. A week later, the boxes arrive. You find yourself with 100 bottles of Burp-A-Lot. Your friend finds himself with 4 bottles of Gas Gulp. Turns out you've been sent colored water. Your friend, Coca-Cola. So you guys try the products out, and it turns out that you, with your 100 bottles, get 1 burp per bottle. Whereas your friend, who's drinking Coca-Cola, gets 25 burps per bottle. Both the boxes are going to give you 100 burps, but what's the more useful parameter to know? The net burp count or the number of burps there are per bottle? Clearly, the number of burps per bottle is a more fundamental quantity. It's also easier to use. All you have to do is open up a can or a bottle, determine how many burps per bottle there are in the container, and then if you've got a box and you want to know how many total burps there are associated with the box, all you have to do is just count the number of bottles. As insipid as this is going to sound, there are situations in physics in which burp per bottle-like quantities have the potential of being really useful. As an example, according to Newton, the Earth produces a disturbance around itself that affects matter. We call this the Earth's gravitational field. So you put a mass in the field and it will feel a force. You double the mass, it'll double the force. You make the mass 4 times as big, the force will be 4 times as big. Clearly, the force quantities that we've been measuring here are not fundamental to the field. They're dependent upon the mass that is experiencing the field. So the question arises, is there a more fundamental quantity associated with the Earth's field? The answer is yes. If we take the force that the mass is experiencing and divide it by the size of the mass, we get a ratio, force per unit mass. If we do that for our doubled mass and our doubled force, lo and behold, we get the same ratio. If we do it for the mass that's 4 times as large, again, we get the same ratio. In each case, the amount of force per unit mass that's associated with this point in space right here, it's the same quantity in each case. That quantity, that ratio, is not dependent on the size of the mass that we're using to test that point. It's a mass-independent quantity. It's not independent of the mass of the Earth. The Earth is the field-producing entity. So it is going to be dependent on that, but it's not dependent on the mass that is experiencing the field. So the first of our conclusions is, as I've just said, that the ratio is mass independent. The second of the conclusions is that what we're being told here is the amount of force per unit mass which is available at that point, whether there's a secondary mass at the point to experience the force or not. And lastly, this is a burp per bottle like quantity, and it's given a special name. We call it the gravitational acceleration. And near the surface of the Earth, that ratio is equal to 9.8 newtons per kilogram. And yes, a newton per kilogram is the same as a meter per second per second. So we didn't make a big deal out of acceleration fields. Okay, the acceleration field is a much more primary fundamental quantity having to do with the Earth's gravitational field. Instead, we focused on the forces on individual bodies. And the reason why is because we wanted to use Newton's laws, and Newton's laws are associated with forces. And so we focused on the force on a particular body. But if we had wanted to be more generic about the field, if we wanted to be more primary, more fundamental about the field that the Earth was generating, what we would have been more interested in was how much force per unit mass the Earth was providing to the region around it, which is to say we would have been interested in the acceleration field. So how is this relevant to what we're about to start studying? Well, in the world of electrostatics, charge configurations generate electrical disturbances in the regions around them. If you put a secondary charge in the field, it's going to end up feeling a force. Whether the force is up or down will depend on whether the charge is positive or negative, and it will depend on whether the field-producing charge is positive or negative. For our purposes, I'm going to assume that the charge is going to feel a force down. As before, we could determine how big that force was, and if we did, we would know something about a specific charge, specifically this charge. But a more fundamental bit of information would be to determine how much force per unit charge was available at that point. That quantity, the amount of force per unit charge that's available at the point, whether there's a secondary charge there to feel the effect or not, is given a special name. It's called the electric field vector at that point. Electric field functions are not a function of secondary charges at the point of interest. In any case, we're going to be dealing with electric field functions literally for the rest of the semester. So just get ready for the thrill. Anyway, more will be said about this probably in the next video. So that's it.